Alright, so today we're going to explore the fascinating world of hydrocarbons and alcohols. These fundamental compounds are key building blocks in organic chemistry and are crucial for anyone studying chemistry or preparing for exams like the MCAT. We'll cover their basic structures, naming conventions, and the unique properties that set them apart. Let's get started. Hydrocarbons are organic compounds that consist solely of carbon and hydrogen atoms. These compounds form the backbone of organic chemistry. The simplest hydrocarbons are alkanes, which have single bonds between carbon atoms and follow the general formula CnH 2n+2. Alkanes are also known as saturated hydrocarbons because they have the maximum number of hydrogen atoms attached to each carbon. The first four alkanes are methane, 1 carbon, ethane, 2 carbons, propane, 3 carbons, and butane, 4 carbons. For alkanes with more than 4 carbons, we use Greek prefixes to indicate the number of carbons, such as pentane for 5 carbons, hexane for 6, and so on, up to dodecane for 12 carbons. These alkanes can also have halogen substituents like fluorine, chlorine, bromine, or iodine, which are indicated by prefixes like fluoro, chloro, bromo, and iodo. For example, chloroemethane has a chlorine atom attached to a methane molecule. Next, let's talk about alkenes and alkynes. Unlike alkanes, alkenes and alkynes contain double and triple bonds, respectively. Alkenes are hydrocarbons with one or more double bonds and are named with the suffix -ine. Alkenes have one or more triple bonds and are named with the suffix -ine. For instance, 2-butene is an alkene with a double bond starting at the second carbon, while 1-butene is an alkene with a triple bond starting at the first carbon. If there are multiple bonds, each bond's position must be specified, like in 1,3-butadiene, which has 2 double bonds at carbons 1 and 3. Moving on to alcohols. Alcohols are organic compounds that contain at least one hydroxyl group, OH. This functional group significantly increases the molecule's reactivity compared to hydrocarbons. The presence of the OH group also influences the naming of these compounds. To name alcohols, we replace the E at the end of the corresponding alkane name with OHL. For example, methane becomes methanol, and ethane becomes ethanol. When the hydroxyl group is not the highest priority functional group, it is named as a substituent with the prefix hydroxy. Alcohols are prioritized over multiple bonds in numbering because of their higher oxidation state. For instance, in 5-methylal-2-heptanal, the carbon chain is numbered, so the OH group gets the lowest possible number. Alcohols with 2 hydroxyl groups are called diols or glycols and use the suffix diol. For example, ethane-1,2-diol, commonly known as ethylene glycol, is a diol with hydroxyl groups on adjacent carbons. Diols can be classified as gem or null diols when the 2 hydroxyl groups are on the same carbon, and fusinyl diols when they are on adjacent carbons. However, gem-e-null diols are rarely seen because they often dehydrate to form carbonyl compounds. So there you have it. We've explored the basics of hydrocarbons and alcohols, their naming conventions, and some unique characteristics that differentiate them. Understanding these fundamentals is crucial for mastering organic chemistry and tackling questions on exams like the MCAT. If you found this video helpful, please give it a thumbs up, share it with your friends, and subscribe for more chemistry insights. And if you're using the King of the Curve app or web app, make sure to like and comment on what topics you'd like us to cover next. Check out the app for more in-depth content and quizzes to test your knowledge. Thank you for watching, and good luck studying.